record. Okay. So dimensions parallel to the neutral axis should be changed. That is what we have understood in the last lecture as well. Okay. So now as you can see here in this particular cross section, there are two steel beams which are fixed to the wooden beam. Okay, so we can convert this steel beam into equivalent wood section. As you can see, I have written there that a wooden beam can be written into equivalent wood section. How we should convert? So whatever the dimension we have parallel to the neutral axis should be changed. Should be changed का meaning है whether you should multiply the dimension by modular ratio or you should divide by modular ratio. Okay, so here it depends on from which material to which material you are converting. If you are converting from weaker material to stronger material, then you will have to divide by m, and if you are converting stronger material to weaker material, you have to multiply by m. So as you can see, steel is a stronger material here, which I am converting into wood, so I am multiplying by m, and steel, if I convert this particular wood section into steel, then I have divided by m. You can see in this particular part, right? So this is what we have understood in the last lecture. Now let us understand this particular numerical which we discussed last time. Many of you were absent. So these all numericals we have discussed. Let us now start with some more numericals. Okay, so this particular numerical we have for today. What is this numerical says? A flitch beam consisting of two 550 cross 50 mm cross 200 mm wooden beams consists of two 50 cross wooden beams of a 12 mm into 80 mm steel plate. Okay, as you can see 250 cross 200 मतलब ये particular section है जिसके center में we have inserted a steel plate or a steel plate rectangular cross section whose dimensions are 12 mm cross 80 mm. Okay, as the cross section is given to you, this is the cross section of the beam. So the plate is placed centrally between the wooden beams as shown in figure. The maximum bending stress in wood, the sigma wood maximum, is given as how much? 12 MPa, and the calculate the bending moment of resistance and maximum stress in steel plate. So we need to understand how can we solve this particular question. So we first of all we need to draw the equivalent section. Now to draw equivalent section, we have to decide whether you are converting steel into wood or wood into steel, and that is completely our choice. We can take any this one. So how we can do that? So which one you try to convert? So let us try to convert this wooden section into steel section. Let us try to convert wooden section into steel section. So if I want to convert wooden section into steel section, what I need to do is, let's say I am drawing this neutral axis. Neutral axis, as you can see. So first of all, whatever the steel section was there, I will just draw that steel section. So my steel section is right now, which is present, is this, right? Now we are converting. So when you are going to convert, what is the golden line we should remember is the dimension which is parallel to the neutral axis should be changed. Now you can see here, if I try to change this particular wooden section, so wooden section में problem आएगा. Why? Because there is no one dimension which is parallel to the principal axis or neutral axis. There are two dimensions because this wooden section is hollow from the center. So in this kind of problems where one material is embedded into the other, it is not simply flitched, it is inserted. So in that case, better to convert a material which will have minimum dimensions to change. Now here, if I want to change this, I need to change this 100 mm as well as the 12 mm dimensions for wood, and then a smaller section, equivalent section of steel I am going to get. Understanding it? So this is how we should think of which one would be easy for us. So that means whatever I'm going to do here with the steel will not going to help me much. It will increase my work. So better let us keep wood as it is and then convert steel, this to equivalent wood. Now let's say 12 mm hoga. So how will I convert? I will just multiply by modular ratio. Now the modular ratio is how much here? Just a minute. Okay. So the modular ratio they have not given. Let us take it 20. So E for steel is 20 times E for wood. So that means my modular ratio is, let's say, 20. So if I want multiply this 12 by 20, which is dimension parallel to neutral axis is 12 for steel. If I multiply that by 20, 12 into 20 becomes 240. So it will be somewhere like this. Equivalent wood section. And apart from this, there is already a wooden section which is already present. So this section. Just a minute. So as you can see, steel we have already converted. Now the dimensions for steel which is converted, how much will be the dimension? So as you can see, this dimension is going to be 12 multiplied by 20, which will be 240 mm. Okay, and this dimension was already, let's say, 100 mm. वो तो 100 mm already था. थोड़ा dimension मैंने exaggerate किया है, but that is fine. Okay, so now you can see ये dotted lines का meaning है कि there are two wooden sections now. There are two rectangles. There is no मतलब ये overlapping है. We have to consider this overlap section. मतलब हमें उसको subtract नहीं करना है कि इतना ही खाली plus sign का ये shape नहीं है. ठीक है? Steel is also there and wood is also there. So that means here we need to calculate the equivalent inertia. Inertia calculate करने के लिए कैसे करेंगे? This is 80 and how much is this? Is 200. Okay. So now let us find out the neutral axis ka inertia. Inertia about neutral axis. How you are going to calculate the inertia about neutral axis? So it is inertia of the yellow rectangle, that is for equivalent wood section, and inertia of the white rectangle, which is for wood section. So this is already a wooden section already present. So how we can multiply? Let us go for now neutral axis ka jo centroid hoga, that will lie over here only. So for equivalent steel section, the dimensions are 240 cross 80 and it is perpendicular to 80. So it is 240 multiplied by 80 cube divided by 12 plus the other dimensions are 100 multiplied by 200 cube divided by 12. So you have to simply add this. So this becomes easy for us. If either rather if we would have converted the steel into wood into steel, that would have given me a hollow section. So उसमें subtract भी करना पड़ता है. Inertia में एक step बढ़ जाता. Okay, so that is why we have chosen this particular step. We have not subtracted. We know that there will be this area, ये जो बीच का area, it will be taken twice in both the rectangles, and it has to be there because the material is such a way. So therefore, now if I calculate, can you give me the answer for this? Neutral axis. Okay. Yes, give me the answer.
Seven 7.69 into 10 raised to 7.
7.69 into 10 raised to 7 mm raised to 4. Okay, fine. So now see here, we know the inertia. Now what is the next step? What is given here is the maximum stress in wood is 12 MPa. Now you know the maximum wood ka jo section hai, it is at what distance from the neutral axis? So if you calculate this distance, that is going to be y maximum. Now for y maximum, according to the cross section, it is 100 mm. So at y equal to 100 mm, the stress value should be 12 MPa. The stress value should be 12 MPa. So ये stress value अगर हमें consider करना है, then according to that we can calculate how much will be the stress in steel and everything. So let us go for that. How we can calculate. So now, okay. So we know that at y equal to y maximum equal to 100 mm, sigma wood maximum is given as 12 MPa, right? Okay, sigma y maximum is given as 12 MPa. So if you know sigma maximum, okay, then we can calculate the moment of resistance immediately, because we know that sigma by y is equal to m by I, which is the formula which you have studied from flexural formula. So if you know the flexural formula, this according to this, m will be equal to sigma wood maximum upon y maximum for wood into inertia of neutral about neutral axis, which is for wooden section only. We have calculated for wooden section. So how much is the sigma for wood? It is 12 MPa, which is given. How much is y? It is 100. And how much is neutral axis ka inertia? It is 7.69 10 raised to 7. So can you give me this answer? How much will be the bending moment or resisting bending moment?
0.92.
0.92. How it will be 0.92?
Into 10 raised to 7 आएगा sir.
Into 10 raised to 7 sir.
हाँ तो 9.2 लिखो ना. 9.2 into 10 raised to 6 Newton millimeter, or else you can write down that as 9.2 kilonewton meter. Okay, you can anyway. Now what is the next question? The next question is to find out maximum stress in steel. Maximum stress in steel. How will you calculate maximum stress in steel? How will you calculate? Any idea? So see here. Now, first of all, what we need to do here is कि we know that y for steel, हमें पता है कि at y equal to 100 mm, ठीक है, sigma wood कितना है? कितना है sigma wood? 12 MPa, right? But you can see in the diagram, the steel is maximum available at what distance? It is at a distance of 40 mm from the neutral axis, right? So we should drop down this sigma value for wood to 40 mm. So let us calculate at y equal to 40 mm, how much will be the value in wood? How much will be the value in wood? So what you can do is we can simply cross multiply. So sigma value of sigma wood at y equal to 40 will be equal to what? How much?
4.8.
It will be of course 40 divided by 100 into 12, right ना? How much it
Yes,
will be? 4.8 MPa कम हो जाएगा
Yes.
वैल्यू. Now ये वैल्यू सिग्मा वुड का कितना है? कहाँ पे है? y equal to 40 पे. So therefore at y equal to 40 mm, what will be the value of in steel? What will be value in steel? Then देखो मैंने बताया था तुम्हें कि whenever we are changing the value of y, we should not change the material. तो देखो मैंने value of y change किया तो material मैंने wood ही रखा. Wood में कितना आएगा? 40 पे find किया. Now when you are not changing the value of y, at y equal to 40, you can use modular ratio to change between the materials. How it is? So y is equal to 40 पे sigma steel में कितना आएगा? तो sigma steel at y equal to 40 upon sigma wood at y equal to 40 will be equal to modular ratio. ठीक है, modular ratio कब तुम्हें relation देता है दोनों stress के बीच में? When you are at same level from the neutral axis. ठीक है, you cannot say that y equal to 100 में कोई दूसरे का लूंगा और 40 पे find करूंगा. That relation is not never exist. The relation between modular ratio will only help you when you are at same level from the neutral axis. So therefore at y equal to 40 मैंने ensure करके लिया, and then I will calculate modular ratio is 20. So now sigma in steel at y equal to 40, I know that it is going to be maximum because steel is available maximum at 40. Okay, and wood का max what value है 4.8. I should not consider 12 here. 12 लेंगे तो wrong आएगा answer. Okay, and that is 20. So if we solve this, so then we will get sigma in steel maximum as 4.8 into 20. How much it will be?
96.
96 MPa. Did you understand this part last color? Here most of the people will go wrong. They will take sigma y maximum, sigma wood maximum as 12, and they will multiply by that, and 240 MPa is the answer. Okay, but that will be wrong. Are you understanding it? So now let us go for the next section. This problem. Okay. So now see again what is the question and how the question will, how we can solve it. Now this is unsymmetric. यहाँ पे symmetric नहीं है कुछ भी. Steel and so there is a cross section of composite beam made of aluminium and steel. So this is aluminium and this is steel. Okay, as shown in figure, the modulo of elasticity are E for aluminium is given and for steel is also given. So you can calculate the modular ratio. Under the action of bending moment about Z axis, that produces a maximum stress of 50 MPa in aluminium. What is the maximum stress in steel? They're saying कि you have to don't calculate any bending moment and everything. Just tell us कि अगर maximum stress steel में आता है 50 M, aluminium में 50 MPa आता है, तो steel में कितना आएगा? Okay, so how we can calculate this? So let us first find out the modular ratio. So what will be the modular ratio? I know that modular ratio is nothing but E for steel upon E for aluminium. Aluminium being the weaker material, as you can see, this is weak for aluminium, right? So I have taken EA for aluminium, or else any way you can use that. AL. हाँ, तो कितना steel का value? It is 200 and aluminium का value 75. How much it will be? Modular ratio?
2.67. 2.67.
2.67. Okay. So once you know modular ratio, what you have to do? You have to convert into equivalent beam. How we can convert into equivalent beam? How we can convert? Okay. Can anybody suggest which I should convert? Aluminium to steel or steel to aluminium? It is better to convert into aluminium. Why? Because we know the maximum value for aluminium, not for steel. Yes or no? Okay. So how we will convert into aluminium? Steel into aluminium. Yes. Can you suggest? बताओ बताओ बैठो मत.
Multiply by modular ratio.
Multiply by modular ratio. So we are converting steel, multiply or divide?
Multiply.
Yes, is it correct? Any other? Yes, correct. Steel we are converting, so therefore we are converting stronger material to weaker material. We have to multiply. So how we can multiply? Multiply which dimension? So dimension which is parallel to the neutral axis. Neutral axis is going to be on horizontal axis, so therefore 30 mm dimension I am going to change. And 30 mm when you multiply by 2.67, how much it will be? कितना होगा?
80.1.
80.1. Okay. So therefore I'll be calculating. This is, let's say, 80.1 dimension. So my steel section will now look like this. Right? This is the new equivalent aluminium, and the original aluminium which was there, so वो तो वैसे ही रहेगा. So this is the original value aluminium. How much was this? So this was 30 mm, right? So you have a composite section like this in this particular shape. So now I know that composite section अगर ऐसा है तो यहाँ पे neutral axis somewhere in the center of this there will be some neutral axis. ठीक है, but वो कहाँ कौन से position पे आएगा that we don't know. So you will have to first find out the y bar of the section. Yes or no? Right? So how will you calculate the y bar of section? Anybody? Can you tell me how will you find out? How will you locate the neutral axis? Yes, quickly.
A1 y1 plus A2 y2 by A1 plus
Yes,
A2.
of course. So let us consider this as my first section. This is my second section. So I will be multiplying A1 y1 plus A2 y2 upon A1 plus A2. Yeah. So now tell me what is A1, area of 1. This is 80 mm, 80 cross 80. अभी 2.67 है ना, ये 2.67 मतलब अगर ये किया तुमने 67 लिया इसलिए 80.1 आया, otherwise it would have been 80 only. So let us take this 80. Let us take this 80. Okay. 2.666666 होता है ना, and 2.666 multiply by 30 करोगे तो you'll approximately exactly अगर calculate करोगे तो 80 आएगा, right? So therefore I am taking it as 80. So let us say this is also 80, this is also 80. So my area will be 80 multiplied by 80, and उसका जो y होगा that will be at 40 mm from the ground, from the origin. Let us take this as my origin 0,0. ठीक है, प्लस व्हाट इज द एरिया ऑफ अबोव सेक्शन, दैट इज 40 मल्टीप्लाई बाय 30, एंड उसका जो y होगा वो कहाँ पे होगा, कैन यू टेल मी उसका y कहाँ पे होगा, तो उसका y यहाँ से 20 पे, सो दिस 80 प्लस 100 है,
100.
वेरी गुड, एंड देन बॉटम में 80 क्रॉस 80 is the area A1 plus 40 cross 30 is the area A2. Now tell me the answer for mm in mm.
49.47.
40
9.47.
49.47. Okay, so 49.47 is the answer for y. So that means we are going to get y bar somewhere here, and we can say this is my centroid, and then we can draw the neutral axis through that. Right, this is our neutral axis. Okay, and which is at a distance of how much, 49.47 mm, right, 49.47 mm. Now once you know this 49.47 mm as y bar, you need to find out the inertia about the neutral axis. So can you tell me how will you calculate the inertia about neutral axis? Yes. Let us start with the bigger rectangle. The bigger rectangle is 80 cross 80 है ना, तो it will be 80 into 80 cube by 12, which will be about its center, जो 40 पे था, right ना, उसका लोकेशन कहाँ पे था, you can see here 40 पे था, but हमें क्या करना पड़ेगा, उसको शिफ्ट करना पड़ेगा, तो शिफ्ट करने के लिए एरिया is 80 into 80 and into distance, तो distance देखो ये 40 है और ये 49.47 है, so I have to simply multiply by 9.47 का square. I hope I am writing directly now. These steps are very common. We have been using this so long. Yeah. Now the second जो rectangle ऊपर है, उसके लिए inertia कैसे लिखेंगे? तो it is 30 multiply by 40 cube by 12 plus 30 into 40 multiply by distance. Now उसका location देखो 100 पे था और हमें उसको 49.47 पे लाना है, तो you can simply write down 100 minus 49.47 का square. I told you these small things earlier as well. So now can you give me the value, inertia? Yes.
2.25 into 10 raised to 12.
2 point कितना?
2.25 into 10 raised to 12.
ये कौन बोल रहा है? रोहित यादव.
हाँ.
अच्छा, ये ISA में रोहित यादव को ही मार्क्स देने वाला हूँ मैं, बाकी लोग एकदम शांत बैठे रहते, मैं भी उनके एग्जाम उनके पेपर चेक करते वक्त शांत बैठूंगा. ओके, यस रोहित बता.
2.25
2.25
into 10 raised to 12.
into 10 raised to 12 mm raised to 4. Yes, thank you. So we have this inertia 2.25 10 raised to 12. Okay, so once we know the inertia, what is the next step? यहाँ पे हम लोग मोमेंट कैलकुलेट कर सकते हैं, because I know that कि this is entire into aluminium, so aluminium का maximum location देखो, ये 49.47 है, ये कितना रहेगा? How much will be this?
120.
कितना?
Sorry, 120 minus 49.
120 minus 49.47.
70.53.
70.53 mm. Now see here. मुझे बताओ, अभी एल्यूमिनियम ऊपर है 50 MPa, राइट? तो मैक्सिमम स्ट्रेस एल्यूमिनियम में आएगा जो एट अ डिस्टेंस ऑफ y इक्वल टू कहाँ पे आएगा? 70.53 mm पे आएगा, बराबर ना? और स्टील में जो मैक्सिमम स्ट्रेस आएगा तो वो कहाँ पे आएगा? वो नीचे वाले फाइबर पे आएगा. आर यू अंडरस्टैंडिंग व्हाई? बिकॉज स्टील, ये देखो न्यूट्रल एक्सिस, हमने इक्विवेलेंट सेक्शन का न्यूट्रल एक्सिस फाइंड किया है, तो ये पोजीशन पे हमें दिख रहा है कि दिस इज द पोजीशन वेयर स्टील इज देयर, बट ये इसका इक्विवेलेंट सेक्शन है. तो यहाँ पे जो स्टील, यहाँ पे जो स्ट्रेस आएगा वो मैक्सिमम होगा, एंड विथ रिस्पेक्ट टू दैट वी शुड कैलकुलेट. सो हाउ वी कैन फाइंड आउट? फर्स्ट ऑफ ऑल, अगर बेंडिंग मोमेंट यहाँ पे पूछा होता तो so we would have calculated easily bending moment m is equal to होता है sigma by y into I. तो हमारा sigma maximum है 50 MPa in aluminium. अगर मैं ये एल्यूमिनियम का लेता हूँ तो ये भी एल्यूमिनियम का लेना पड़ेगा और ये भी एल्यूमिनियम का. तो तीनों हमारे पास वैल्यूज है 50 divided by y is 70.53 into my inertia is 2.25 into 10 raised to 12. So if you get this is in Newton millimeter, जो भी आंसर आएगा you will get it. Now let us go for how to calculate maximum stress in steel. How to calculate maximum stress in steel. तो अभी देखो कैसे फाइंड करेंगे. So I know that कि at y equal to 70.53 my aluminium का जो maximum stress है वो आना चाहिए and which is coming out to be 50. बराबर है. इतना सबको समझ रहा है कि at this distance you are getting maximum stress 50. बट अगर ये वाला एंड की बात करूंगा यहाँ पे तो here the aluminium में stress तो आएगा but it won't be maximum because it is at a distance of 49.47. ये symmetric नहीं है ना अभी. Therefore it is at a distance of 49.47. So let us find out. We know that कि स्टील में जो maximum stress आएगा वो यही लेयर पे आएगा. Because अगर ये distance देखा मैंने न्यूट्रल एक्सिस से तो as compared to this distance is greater. So स्टील में जो maximum stress आएगा वो ये पॉइंट शेप है. तो मतलब अगर मुझे यहाँ पे स्टील में स्ट्रेस चाहिए तो पहले मुझे यहाँ पे वुड में सॉरी एल्यूमिनियम में कितना आएगा वो इक्विवेलेंट सेक्शन में वो फाइंड करना पड़ेगा. सो देखो मुझे y चेंज करना पड़ेगा. दैट इज व्हाई मैंने मटेरियल सेम रख रहा हूँ मैं. तो मैं अभी क्या लिखूंगा देयरफॉर एट y इक्वल टू 49.47 mm व्हाट इज माय सिग्मा इन एल्यूमिनियम. सी यार मैंने बोला है तुम्हें कि जब तुम मटेरियल सेम रखते हो y चेंज करते हो तो यू हैव टू क्रॉस मल्टीप्लाई एंड गेट द आंसर. So that sigma in aluminium at y equal to 49.47 is equal to कितना हो जाएगा वो? So that will be 49.47 divided by 70.53 multiplied by 50. Tell me the value.
35.07.
Not 30.
35.07.
35.07. Very good. So I know the sigma aluminium का value at 35.07 है. Now this 35.07 ये जो value है that is in aluminium. But वो position पे देखो यहाँ पे actual में this is the equivalent section right? Actual में कौन present है steel. तो अभी मैं material में change कर सकता हूँ by remaining at same location of y. So therefore now I can say that कि sigma in steel which is at y equal to 49.47 divided by sigma in aluminium which is at same distance 49.47 is equal to कितना है sigma in steel that is the question mark वो हमें पता नहीं है. Sorry, that is equal to modular ratio. I should write down that is equal to modular ratio. Why? Because when I am writing the modular ratio का equation I am mentioning or I am keeping y value same. Always keep in mind. Okay, so this is equal to 2.67. What we should take. And if you know now this value is unknown. ये तो unknown है question mark. This value is known to me. How much is this? 35.07. So now can you tell me how much will be the maximum value in steel? Sigma maximum value in steel that is nothing but sigma in steel at y equal to 49.47. How much?
93.52.
93.63. 63. अच्छा ठीक है अभी जो आंसर दे रहा है वो ले रहा हूँ मैं. 91. Now can you tell me sigma steel at y equal to this distance? ये distance कितना होगा? ये वाला ये 70 में से ये 40 गया तो बचेगा 30.53 राइट. यस और नो? बराबर ना. तो ये डिस्टेंस पे स्टील खत्म हो रहा है ना. तो कैन आई कैलकुलेट अभी स्टील का मुझे वैल्यू पता है तो 49.47 पे तो मैं स्टील का वैल्यू एट y इक्वल टू 30.53 पे फाइंड कर सकता हूँ क्या? यस और नो? क्या कैसे फाइंड करेंगे? तो 30.53 डिवाइडेड बाय 49.47 into 93.63. Now give me the value.
57.78.
कितना?
57.78.
78. Okay. Now can you draw the bending stress distribution? The bending stress distribution for this entire section. So let us draw first for wood section and then for steel, or let us first draw for steel and then for wood. तो स्टील के लिए अगर मैं क्रॉस सेक्शन ड्रॉ करना चाहता हूँ स्टील के लिए तो अभी देखो ये मैं पहले जीरो लाइन लेता हूँ. हाँ,
सर
Steel पे
इनर्शिया ज्यादा नहीं है थोड़ा न्यूट्रल एक्सिस के अलावा?
भाई तुमने कैलकुलेट किया है, मतलब तुम लोगों ने.
हाँ सर 7.2 into 10⁻⁶ आना चाहिए.
Is it true? One second, check it so that we'll make it corrections. All of you, check it and give me the correct answers. Yes. Are we getting it?
सर एक मिनट कैलकुलेट कर रहे हैं.
Yes, yes. Correct answer. Yes, Arya Bansode, roll number 1. Are you there?
Yes, sir.
So, calculator है?
Yes, sir. Doing.
How much?
सर 7.2 into 10⁶ आ रहा है.
यस सर.
हाँ सर 7.2.
Yes, sir, 7.2 आया. That is first.
Let us make some corrections now. तो ये आंसर यहाँ पे चेंज होगा and because of that बाकी मुझे I don't think कि बाकी कुछ चेंज होने वाला है because बाकी सब हमने इनर्शिया कहीं पे यूज ही नहीं किया, right? 7.2 10⁶6 ना?
10⁶ सर 6.
खाली यहाँ पे वैल्यू चेंज होगा ना?
हाँ.
Okay, and because of that here there will be some change. What how much is this answer?
5.14.
कितना?
5.1. 5.1. And
10⁶.
6.
Good, very good. So rest all will remain same. Now tell me how we were drawing this particular this one. तो अभी देखो स्टील में स्टील का मैक्सिमम पोजीशन यहाँ पे है जो 30.53 पे है और स्टील का वैल्यू कितना है 57.78, राइट ना? So I should draw 57.78 MPa value, and what is the maximum value we have? 93.63. So that means ये 93.63 होगा यहाँ पे, right? बराबर है. और ये join कैसे होगा? Right? So this is my bending stress variation for steel. Are you getting this? Okay. Now tell me what will be the maximum stress in aluminium? What will be the maximum stress in aluminium? How much? 50 है ना? लिया है हमने 50. कितने डिस्टेंस पे? Y से 70.53 पे, मतलब ये टॉप लेयर पे. ये 57 है तो उससे थोड़ा कम, तो मैं यहाँ पे लेता हूँ. This is my 50 MPa. Now tell me ये लेयर पे कितना आएगा स्ट्रेस एल्यूमिनियम में? ये लेयर पे कितना स्ट्रेस आएगा? तो देखो वो हमने फाइंड ही नहीं किया. ये 57.78 है, उससे मॉड्यूलर रेशो से डिवाइड करेंगे तो यहाँ पे मुझे वैल्यू मिलेगा. तो ये जो वैल्यू मिलेगा वो कितना रहेगा? दैट वैल्यू विल बी 57.78 divided by modular ratio which is 2.67. Can you give me how much is this value?
21.64.
21.64.
640.
अच्छा रुको ठीक से लिखता हूँ. 21.64, right?
हाँ.
So I should get a value of 21.64 and then I should join this. Are you understanding this? Now what is this? This is your bending stress variation for aluminium. And how much is this value we got? Did you understand? बिकॉज वी वर ऑन सेम लेवल, तो मैंने बोला है सेम लेवल पे रहोगे तो मॉड्यूलर रेशियो से तुम्हें मटेरियल में चेंज करके वैल्यू मिलेगा, ठीक है, यू आर डिवाइड और मल्टीप्लाई व्हाटएवर. आर यू गेटिंग दिस? yes or no?
Yes, sir.
Yes, sir.
Yes.
So this is for unsymmetrical sections. Okay, sometimes they may ask you to draw this kind of bending stress variations. Okay, so you should be very careful about how we should draw the bending stress distributions and so on. Okay, are you understanding this particular part? Any doubt till now? Yes. No doubt. In this as well. Okay. Now question number 3.13 I have not written. Let us write down. Let us take one more question based on the whatever we have studied up till now. We have studied flitch beams and bending stress. Okay. So there is one question which I came across. Just a minute. By that time, if you have any doubt, you can ask me. Just give me 1 minute. One question which I have snapped in my mobile. We will solve that. By that time, I will just put this